In early astronomy classes or astrodynamics classes, one of the very first principles that we learn about is the principle of apogee and perigee. Apogee, the furthest point from the planet Earth, and perigee, the closest point to the planet Earth in an orbit. In this video, though, I'm just going to prove to you that relative apogee and perigee, as you're seeing depicted here, are total lies. So let's just dial into a particular time. Let's say this 6 o'clock point, right when satellite 1 is crossing satellite 3's V-bar. So, okay, first question, is satellite 5 at perigee right now? So here's satellite 5. There's the Earth, and here's satellite 5's orbital trace. Is satellite 5 at perigee right now? Okay, obviously not, because it's clearly closer to the Earth right there, right? Is satellite 4 at apogee right now? Well, obviously not, because its apogee is right there, right? Is satellite 1 at apogee or perigee right now? No, obviously not, because here satellite 1 will be further from the Earth. So I guess we would argue that right here is satellite 4's point of apogee, right? This is clearly the point that it's furthest from the Earth. And I guess we might also argue that satellite 2 has a higher point of apogee than satellite 4 does, right? Okay, well now how do you feel about it? Same exact scenario, is satellite 4 at apogee or perigee right now? Yes? No. Yes or no? What is it? Is satellite 4 at apogee or is satellite 4 at perigee? Is this frame true? Is this frame true? What's going on here? Alright, so this mind-blowing experiment is designed to teach you that relative motion can trick your brain into seeing things that are not actually part of inertial motion. When you set your relative frame off of one satellite's inertial line, you get different relative motions relative to the other satellites in that same inertial frame. The truth of this scenario is that satellite 1 has 0 eccentricity. And you might look over here and say, well, satellite 1 has 0 eccentricity, then how could it possibly be closer to the Earth here and further away 12 hours later? Well, actually, it's not closer to the Earth. What's actually happening in this frame is that satellite 3 is further away from the Earth. So let's go into the orbit system of satellite 3 and turn it on for all windows. Here you can see there was a hidden shape around satellite 1 all along. The same NMC that you're seeing here is in this scenario over here. And that same inertial line that you're seeing here is also on satellite 1, moving up and down relative to the frame on the right. It can be incredibly dangerous in RPO to bias our minds to any one reference frame. The truth is that all 4 of these satellites could be said to be in NMCs around satellite 1. But what that means is that when satellite 2 is in an NMC around satellite 1, it's also in an NMC around satellite 4, or satellite 3. Here, satellite 2 is clearly in a large NMC around satellite 3. In fact, you can say it's double the size of the NMC that it is around satellite 1. So if we step through these points, satellite 2 is clearly below satellite 3. The similar thing to what you're seeing in this window here. In fact, it's twice as below satellite 3 as it is of satellite 1. And then if we go 6 hours, they're all on the same line, which is exactly what we see here. And if we go another 6 hours, now satellite 2 is clearly twice as far from satellite 3 as it is from satellite 1. So while in this frame it might seem like they're all in the same NMC relative to satellite 1, which they also are in NMCs around each other. And if you bias yourself to any one relative motion frame, you will lose the idea that relative motion is relative. It is purely tied to the relative center of reference that you're looking at, and not anything that is actually physical. Despite the fact that you're seeing apogees and perigees for satellite 1 over here, satellite 1 is always keeping the same constant distance from the Earth. The reason why it appears to have apogee and perigee is because the satellite that it's referencing off of does change its position relative to the Earth. To put it another way, if you're in an NMC around me, I'm in an NMC around you. Mind blown.